So hi all again. So now we are going to see the answer for antennas and RF concepts questions, quiz questions or interview questions, part 2. Okay, part 2 answers. So if antenna has size of 10 lambda bar 10 lambda at 5 gigahertz has the gain of 10 dBi, when the same size antenna designed at 10 gigahertz, see, remember 10 lambda is 10 lambda is the size of the antenna. I said the antenna. Okay, 10 lambda size of the antenna. Actually, size of the antenna, and at 5 gigahertz has the gain of 10 dBi. So when same sized antenna designed, antenna has the size 10 lambda cross 10 lambda at 5 gigahertz, which means so 10 lambda, which means lambda, the frequency, the lambda corresponds to 5 gigahertz frequency. So then when the same size antenna designed at a frequency of 10 gigahertz, okay, same size antenna designed at a frequency of 10 gigahertz, then what will be the gain of the frequency? So that's why, if your lambda is, size of the antenna is simply 10 lambda, irrespective of frequency, then it should have almost equal gain. Okay, ideally it should have equal gain, but here what we are saying is that so lambda corresponds to 5 gigahertz. So when you use same size aperture for designing, for realizing antenna at 10 gigahertz, then the gain will be higher than that at the 5 gigahertz. So ideally it should be 20 dBi, but it will not be that, because there are matching issue, many issues are there. So that's why the comfortable answer is that higher gain that at the 5 gigahertz. Okay. So again I repeat. So here 10 lambda is not, it's not a general size. So lambda corresponds to 5 gigahertz. Okay. So has the gain of 10 dBi. So when the same size antenna is same size, means same size aperture, it should be same size aperture is designed at the frequency of 10 gigahertz, then what will be the gain? Obviously, because gain is directly proportional to frequency for a given size of the antenna size, means aperture size. Okay. The next question is antenna radiation patterns can be measured directly at near field without using. That's not true, because without Carter chamber we cannot measure the radiation pattern. A very near field, comfortable near field. Okay, we need to go for a far field only. Next is good impedance matching enhances the power transfer, therefore SNR. Yes, correct, because the amount of power getting reflected, so if you will be reduced when you have a good impedance matching, therefore the power transfer, which in turn results the high, improved SNR. Okay, see, improved SNR means it is not the only factor. Say it is one of the factor that improves the SNR. That you should remember, because SNR is a function of many parameters. Okay. So we cannot just should not confuse with that. So good impedance matching enhances the power transfer. Therefore, it is one of the factor that improves the SNR. That you should keep in mind. State the law that describes the magnetic change in magnetic field results in change in electric field. It is straightforward one. So change in magnetic field results in electric field. It is Faraday's law. So at far field E and H are orthogonal but not in phase. No, false, because far field both should be in phase. Otherwise, so in near field only we will get, in a near field only it will not be in phase. Antenna is a transducer. It's not a microprocessor, neither amplifier, because it's a passive device. It transduces the electrical signal from the electromagnetic waves. Next is that at higher frequencies, which antennas are widely used? See, wire antennas, aperture antennas are widely used. Okay, wire and aperture antennas and printed antennas are widely used, because wire antennas, at high frequencies, it is so high frequencies wire antennas cannot be used, because it is not that we cannot use. So it will be prone to higher harmonics, and then so because each wire, each component, it will become act as too much reactive components. So that's why we do not prefer wire antennas. In general, okay, we do not prefer wire antennas in higher frequency, very high frequencies. Higher frequency in the sense, so more than C band, or more than that, because more than C band or X band or K band. I am sorry, it's not a specific one. Higher frequencies means for somebody it is 100 megahertz also higher frequencies. And 100 megahertz they have been using wire antennas. So I'm sorry. Higher frequency means above C band or X band. X band which means 8 to 9 gigahertz, 8 to 12 gigahertz or 12 to 18 gigahertz. Okay. In those frequency ranges, aperture antennas and lens antennas, printer antennas are being used. So the answer is B and C. Okay. Next is VSWR2 corresponds to a return loss value of about 10 dB. Okay. So here the thing is that return loss means you should say only 10 dB, not minus 10 dB, because when you are talking, because it's already you are saying that loss. If you are telling minus 10 dB, then it will become gain. So that's why the symbol, the sign is very important. Okay, it is 10 dB only. Thank you. Thank you all. Keep watching. Thank you.